Hi geometry students, welcome to the lesson for 6.6. It can be found on these pages, and we are not having any new vocabulary with this lesson. We are going to do what I'm calling a summary of quadrilaterals. So we're going to summarize what we've learned so far in this chapter and do some example problems to go along with that summary, the kind of tree diagram we're going to draw in a sense you could call it that. And so let's start with this. So this is 6.6. Here we're going to have the summary of quadrilaterals. And then I'll go with the paragraph first before I draw the little diagram over here. But each shape in the diagram we're about to draw, so I'll say in this diagram, each shape in this diagram has all of the properties of the shapes linked above it. And that's pretty important, so I'm going to put an exclamation point there. And the further down you go, the more specialized they are. So the all-encompassing one, any four-sided shape you can come up with. We start with quadrilateral. So that goes up here at the top. Now if you can think of all the ones we've learned about so far, why don't we do that over here off to the side. What I'm about to write down here you can leave out. This is just going to be for us to look at right now. So you do not have to write this down right now. But we have quadrilateral. So I'll write that down though. Don't have to write the green stuff that I'm drawing right now. You do not have to write this down. This will be a good test to see if you're actually listening instead of just copying things down and not listening to this. What else did we learn about kite? We learned about a kite. We learned about parallelograms. We learned about squares. Rhombuses or rhombi, so a rhombus, a rectangle, and I'm leaving something out there, trapezoid and isosceles trapezoid. There we go, isosceles trapezoid. So these are the ones we're trying to put over here. So I use quadrilateral, that's good. How do the rest of these branch off of there? So we basically have three different things happening. We could have one set of parallel sides, one pair of parallel sides, that would be a trapezoid. So that gets rid of that one. We could have two sets of parallel sides, that would be a parallelogram. Or we could have no sets. So just any old quadrilateral without any parallel sides would have no sets. There was also one other one that had no sets of parallel sides, and that was a kite. So we saw that in the last lesson, I believe that was, yes. So with a kite, there's no pairs of parallel sides. So that gets rid of that, and that gets rid of that one. So where do we categorize the rest of these? We saw in lesson 6.4 that squares, rhombuses, and rectangles were all special types of parallelograms. So that should all come underneath here. And then an isosceles trapezoid is just a special type of trapezoid. So that should definitely come right here. I'm going to abbreviate that like this. So isosceles trapezoid, that belongs there. And then we saw in 6.4 that a square was a special type of both a rhombus and a rectangle. So next in specificity, branching off the parallelogram, should be a rhombus and a rectangle. So 4 congruent sides, 4 congruent angles. They're branching off here and here. And then under both of those, so these are going to reconnect actually, under both of those you have a square. A square could be a special type of rectangle or rhombus, and it's also a special type of parallelogram. So as I go down here, I know a square is both a rhombus, a rectangle, and also a parallelogram because it's linked underneath a parallelogram, and it's also a type of quadrilateral. So quadrilateral, parallelogram, rhombus, square would all apply to square. An isosceles trapezoid would be a trapezoid, and it would be a quadrilateral. A parallelogram would only be a quadrilateral. A rhombus would be a parallelogram and quadrilateral. A kite would be a quadrilateral. A rectangle would be a parallelogram and quadrilateral. And a trapezoid would be a quadrilateral. I think I hit them all. So as you go up here, you're getting less and less specific. As you move down, you're getting more and more specific. And let's, on the next page here for me, let's do a little recap. Let's call it that. This is a recap of the quadrilateral. So a quadrilateral, what do they look like? A quadrilateral is any four-sided polygon, so it's got nothing really special about it. It could have some special things going on with it, but we say generally quadrilateral, it doesn't have to look like that. It's just one type of quadrilateral, one example of a quadrilateral. So it's any four-sided polygon. What's a kite look like? So from our previous lesson we saw that it had two pairs of consecutive congruent sides. So something like these two would be congruent and these two would be congruent. Parallelogram. What was special about a parallelogram? Here's an example of a parallelogram. It has two pairs of opposite parallel sides. A trapezoid just had one, so that was the difference between a parallelogram and a trapezoid. A trapezoid just has one pair of parallel sides. Not perfect pictures, but I think they're getting the point across at least. A rhombus has four congruent sides, but not necessarily four congruent angles. Maybe if it was a square, which is a special type of rhombus, then it would. But a rhombus is like that. Rectangle. What's special about a rectangle? It has to have four 90-degree angles. So something like this. A square has the properties of a rhombus and a rectangle. So these are all 90 in the corner, and these are all congruent. And then I can't leave out our good friend Isosceles Trapezoid. Let me make that S a little better. Isosceles Trapezoid. So what's special about an Isosceles Trapezoid? It is both a trapezoid, so it has one pair of parallel sides, and the legs are also congruent. So this is congruent to that, and that would be parallel to that. And so let's check out a couple examples to see if we truly understand the differences between these shapes. Okay, so let's see what we got here. I'm going to go first with drawing like this. And I'm going to tell you here that you cannot trust the way the pictures look on these. So you cannot trust the way the pictures look. Yep, good to go there. So let's say we have something like this. And then in the corner, this is our original color still. You can put that and that. And that is all I'm going to say with that one. So 90 degrees right there. And here's what we're trying to do with something like this. What is the most specific name? That's the important part here. Most specific. So what's the most specific name for this quadrilateral? I'm not asking you what it could be. I'm asking you what is the most specific name for it. And one other important thing, we've said it already, but the drawings are not necessarily to scale. So we can't trust the way the picture looks on these ones. Drawing is not necessarily to scale. And let's call these points M, A, T, and O. We'll go with those. And that brings me to these pictures here too. You could actually spell moat, which is what this is, the water around the castle, the moat. Or you could spell atom with those letters. And maybe there's even another one you could spell. It's not coming to me right now though. So this is a model of an atom. Electrons, protons, neutrons, etc. So what is the most specificity you can apply to this one right here? And at this point I want you to take out your different color. So get out a different color. Whatever I draw in red, you need to draw in your different color. This is what's here originally in black. What I'm going to add in red is stuff we can actually prove must also be true. Since these are parallel or perpendicular to each other, kind of just gave it away there. Since they're perpendicular to each other, that means these two lines must be parallel to each other. That was a theorem we learned a while back. But two lines perpendicular to the same line means those two parts are parallel. These two segments are going to be parallel to each other. So let's write that in as a justification down here. I'm going to leave a little space to answer the question, but let's do that in a different color because two lines are perpendicular to the same line. OT is going to be parallel to MA. So that's why that was true. That's why I could add that. Is there anything else I can add here? So could I say that this one is the same length as this one? It doesn't look like it, but maybe not. I can't really say. I don't know. There's nothing in here that allows me to prove that. Can I say that this side's parallel to this side? Doesn't look like it, but again, can't trust the picture. But there's nothing in here that would prove one way or the other. This, though, definitely has to be true. And this is really the only thing that must be true, other than that it's a four-sided polygon. It's a quadrilateral. So let's see, what's most specific here? What does that appear to be with the most specificity? That appears to be a trapezoid right there. So this one set of parallel sides, that's what we have going on here. This one, you would say, as specific as you could possibly get, this would be a trapezoid. Let's do one more like this. And we'll do some more like this together in class 2. This one I'm going to draw using my square tool, but you may not be able to prove that it's actually a square. And so why don't I just go with those same letters again. And I'm going to add some things here to this picture to help you determine what the most specific name for this could be. And I'm going to draw in the diagonals for this one. So let's draw that in our original color. Use a little lighter, thinner line to do that on mine. So let's say that that's true. And also we're going to assume that this is true. That one, that one, that one, and that one are all the same. So you look at that, this picture, atom, moat, whatever you're calling that. I guess you shouldn't say moat because that would be M-O-A-T, and that's not the order of the letter. So we'll go with atom on this one, A-T-O-M. Does it look like a square? Sure. Is it a square? Can you say that for sure, though? I would argue, and you should say no, because we don't know if these, right now we don't know if these are actually 90, we don't know if these are congruent, but there is a theorem that tells us that if all these are the same, that means this has to be, if you go back to Theorem 6 point, I think it was 613, let me just verify that, yes, so if you go back to Theorem 613, it says if the diagonals are like this, if they're all the same, and if this whole one equals this whole one too, that you actually have a rectangle. So we can be as specific as that based on what's in the picture. So I'll say this is true, and then let's get out our different color to justify that. This is going to be by Theorem 613. and we'll just say see your 6.4 notes for that. So if you're wondering what did that theorem say again, write that down, refer back to that. So go back to the 6.4 notes right now, look at that theorem, and see how that applies to this. So this is as specific as you can get for that. All right, let's move on to the different type of example where I'm going to give you a shape and you're going to tell me what it could be, not what it must be at the very least, but what it could be. So which ones could be, or which kinds of quadrilaterals might fit what I have here. I'm going to move this down just a little bit, and I'm going to write in up here the question. So here's the question: what kinds of quadrilaterals could, that's the key word there, which ones could, not which ones, or what is the most specific name for it, but which one could meet. So this is going to include more shapes. These ones, you should just be giving one answer. These ones might have more than one correct answer. So which ones could meet the conditions shown. And again, on this one, I'm going to draw shapes that might look like something, but you can't assume that they are. So we're going to say drawings are not necessarily to scale. And I'll get out my drawing tool here just to make these look nice and clean. You could use a straight edge if you wanted to, but let's say I had a shape like this. And that one, here we go. We can put all this on here as well. I'm going to tell you, you can at least assume that that is true. So, and that's it. So if that's all you can assume is true, which ones could meet the conditions? So is this possibly, let's go back to our list. I'm going to recopy that list down off to the side. Let's look at this list here, write all these down. This one I do want you to write off to the side in a different color. So off to the side next to example 2, let's write all those possibilities down. So quadrilateral, this is your different color now. Quadrilateral, kite, trapezoid, isosceles trapezoid, parallelogram, rectangle, rhombus, and square. So these are your choices. You may be able to pick more than one. So could this be a quadrilateral? Yeah, absolutely. So that's actually one. I'm going to have you, yes, it's in a different color, but we aren't going to draw that one. Sorry, if you wrote that in, just kind of scribble it out. I know a lot of you probably use pen or marker for that. My bad on that one. But these are the 7 we're going to choose from. Quadrilateral, they're all going to be quadrilateral, so I don't feel like that's helpful to be writing that down. Could this be a kite, though? What makes a kite a kite? A kite is a kite because it has 2 pairs of consecutive congruent sides, but they all can't be the same. That's not possible. So could this be a kite? I would say no on this one. So not a kite. Could it be a trapezoid? In a trapezoid, is it possible to have 4 congruent sides? Well, if it has 4 congruent sides, it must at least be a rhombus. So let's write that down. And a rhombus is a special type of parallelogram. And so if you go back to here, one more, there we go. If something that has to be a rhombus, then you would say, yeah, it could be a parallelogram, it could be a rectangle. I'm sorry, is it possible? I think so, yes. I gotta collect my thoughts here. It could be a rectangle, could be a square, but can it be something that has, if it's a parallelogram, it has 2 pairs of parallel sides? If it's a trapezoid, it only has 1. Can it have both 2 pairs and just 1 pair at the same time? No, so that's going to eliminate trapezoid and isosceles trapezoid. So over here, we can actually say rhombus. Could it be a rectangle? Does it look like a rectangle? No, but again, the drawings are not necessarily to scale, and so you could have a rectangle, don't draw this off to the side, but this is just to help us see what's going on here. If I drew the shape like that instead, that still looks, it still has the same information as that. It's possible that these could be 4 right angles. Is it probable looking at this? Probably not, but is it possible? Yes, it's possible. So that could also be a rectangle. So again, you didn't need to draw that, but this is helping me figure this out as I go. Is it possible that's a square? Yeah, for the same reason, the same picture I just drew there. So it could still have this information plus more. And is it possible that that's a parallelogram? Actually, it has to be a parallelogram because it's a rhombus. It has to be a rhombus, and so it have to be also a parallelogram. So it has to be a rhombus and a parallelogram. It could also be a rectangle and a square. So which ones could meet the conditions? We say all 4 of them could meet the conditions. You may want to go back and pause, rewind that a little bit, re-listen to that. This concept tends to be a little tougher for students to catch on to. We're going to do a couple more though too, so maybe go back to the ones you were a little shaky on after we're done going through everything. Now this one I'm going to draw to make it look the same. You know what, I'm just going to actually copy and paste this. And so why don't I do that, copy, or just duplicate it, there we go. But I'm going to get rid of a couple of things here. So this, I'm going to get rid of that, I'm going to get rid of that, and instead of those 2 things, I'm going to add parallel here and parallel here. So let's go back to our choices here, and let's see what this could be. Alright, so let's draw some. I'm going to draw some. You don't have to draw these pictures, but again, this is a good idea as you're going through problems like this, to draw the pictures to see if it's possible to make it fit. So is it possible to make it fit a, let's start here actually. Let's go with square first. So if I drew the picture like this instead, I'm trying to make it look like a square. If I drew the picture like that instead, could that be a square? I would say yeah, because that could be the same right there and there and there and there. They all could be 90. These could be parallel, these 2 sides right here. These would have to be parallel. These could also be congruent. So I could add that to that, and everything still holds true in the picture. That's not an impossible picture. So this one I would say square definitely holds. If something's a possible square, a rhombus is also a possibility. So if a square is a possibility, that's a special type of rhombus. That means a rhombus is a possibility. If a square is a possibility, that also means a parallelogram is a possibility too, because that's attached underneath it. Same thing with rectangle. If a square is a possibility, a rectangle is also a possibility because that has 4 90-degree angles just like a square does. Okay, so we've done those ones. Could this be a trapezoid? Not does it have to be a trapezoid, but could it be a trapezoid? So with parallelograms, was it possible that this side was parallel to this side? Yes. Here, it has to at least be a trapezoid, or it has to at least have 1 pair of parallel sides. That's probably a better way to say that. And so if it has at least 1 pair of parallel sides, then yes, it could be a trapezoid here. Could it be an isosceles trapezoid and a trapezoid at the same time? Yes, an isosceles trapezoid is just a special type of trapezoid, and it actually would be isosceles as well. So I would say isosceles trapezoid would definitely fit, and since isosceles trapezoid fits, anything above it also is going to fit, so trapezoid would also fit. Now, does a kite work? So a kite, remember, has to have different parts here, so something like that and that, and they have to be consecutive congruent. So these ones are opposite congruent, and because of that, that eliminates a kite. So I would say no to the kite. The kite does not work. This one we already dealt with that one. So kite doesn't work, so I'm going to erase that comma because that's it. I say that's it, but we actually had 6 out of the 7 possibilities. Is it always going to happen like that? No. So this one, no, with 6, this one had 4 possibilities. And let's do one more here. And again, if you need help, ones like these, we will do some more in class, but we're going to I would like you to go back, rewind, and rewatch things. If something wasn't clicking with you, try to listen to it 2, 3, however many times you need to listen to it until it starts clicking. Okay, I'm really going to draw this one kind of funky looking because I'm trying to get you to think about it without thinking about how it looks, but more based on what is actually given to us that we can assume true in the picture. So this one I'm going to tell you that this and this are the same and that this and this are the same. Definitely doesn't look like it, but here we're saying the diagonals bisect each other. So why don't we actually write that down underneath here. The diagonals bisect each other. So that's a big piece of information. That's a big clue as to what you could do with this, or what kinds of theorems we're going to use. So if we go back to our parallelogram theorems, I'm going to actually pause it and bring that up a second. And here we are, 6.3, lesson 6.3. This was one of the things we said had to be true, or if it was true, you actually had a parallelogram. That's the better way to say that. So if the diagonals bisect each other, that means it would be a parallelogram. Okay, so let's go back to this. That's a possibility then. And I could even say it, the most specific I could be would be a parallelogram. So if this were worded like this one, you would actually write parallelogram. That's the most specific you could be. But this one is saying what could meet the criteria. So would a rhombus meet those criteria? If you were to draw a rhombus in, would it be true that this would equal this and this would equal this? Do the diagonals bisect each other in a rhombus? Yes. And that's also going to be true because a rhombus is just a special type of parallelogram. And why don't I just put a single, I've been going singular the whole time and made that plural. So parallelogram, rhombus. Alright, that takes care of rhombus. A square, is that a special type of parallelogram? Yes, so it's possible that since it works for a parallelogram, it's possible that a square would also have that going on. So why don't I draw a square just to visualize that, to help you see that. This would be congruent to this, and this would be congruent to that in a square. That would be the case as well. If it's a square, it's also going to be a rectangle, and so that would also still hold true. In the square and the rectangle, we could actually say that they're all the same, so we could put the same number of marks on each one, but it would hold true that this one is the same as this one, and this one is the same as this one. So less specificity here. We're just saying which ones could meet that criteria. So I would say also rectangle. Now is there more? Could I say trapezoid, isosceles trapezoid? If you look at the diagonals of a trapezoid or an isosceles trapezoid, here, let's just draw an isosceles trapezoid. Let's see, do the diagonals bisect each other? And so something like this and this one, are these two the same in that? And is there any way you could draw a trapezoid where those two would be the same? I would argue no. And so you could draw trapezoids all day long, and this would never be the same as this. If you're going to make them the same, it's going to force it to become a parallelogram. And parallelogram and trapezoid are distinct shapes. One is two pairs of opposite sides parallel. The other one is just one. So it's impossible to draw a trapezoid that has diagonals that bisect each other. So this one, that's not going to work. So this one, we took care of that already. If a trapezoid doesn't work, it's not going to work for an isosceles trapezoid. If an isosceles trapezoid doesn't work, trapezoid not going to work either here. And a kite, so if you draw a kite, do the diagonals bisect each other? Is that a possibility? And so do both pairs of diagonals bisect each other? This one I'd say yes and yes here, but is this going to be the same as that? No. And you can draw kites all day long, and you'll never be able to draw one where the diagonals bisect each other. That's not a property of kites. So this is it. So these pictures, again, you didn't have to have these pictures drawn in, but you did have to have, I wanted you to have this listed down. Above that, let's write choices. These were our choices for these types of problems. And then here, one final thing to wrap up this lesson. Let's do this in a different color even to make it stand out. So I'll keep my different color here. For these types of problems, it will be helpful to draw the shapes as shown first, so like they are here, here, and here, if that was in your book, to copy those down on your page, and then draw examples of how each shape could fit the criteria. And that's exactly what I was doing over here. That was what this stuff was. I was trying to draw the shape so that the criteria was still holding true, but that it also matched up with one of these choices over here. So I hope you found that helpful. We will tackle some more in class. If you're in my class, we'll take a look at some more examples. And yeah, go back again, rewind, go back, review these things. These ones especially take a little bit longer to catch on to. So go back as needed and review, and hopefully you found that helpful once again. I will catch you guys later.